All right. Buckle up, everyone. We're diving deep today.
It's exciting.
It is. We're talking YOLO model training.
YOLO.
Yep, you only look once. It's all about object detection, teaching computers to see objects and images and videos. We've got some great material to dig into, stuff that I think will really help you understand how this all works.
You know, it's funny. We talk about computers seeing, but it's not really seeing like we do.
Right, it's more like teaching them to recognize patterns, to pick out specific things from a jumble of visual information.
But the results are amazing. I mean,
Yeah.
the things you can do with object detection.
It really is mind-blowing. Think about it. Self-driving cars, they released on this. Being able to spot pedestrians, other vehicles, traffic signs, all in real time.
And it's not just cars. Medical diagnoses, spotting anomalies in scans, that's getting a huge boost from object detection.
And what about, let's say, someone's passionate about wildlife conservation? They could train a YOLO model to identify and track endangered species in the wild.
Exactly.
Yeah.
The applications are endless, really. It's all about training the model to see what you want it to see. But how do you actually do that? Where do you even begin?
Well, it all starts with the data.
The data, yes. That's the foundation of everything.
You got to teach the model what to look for, right? It's like showing a kid a bunch of flashcards. This is a cat, this is a dog, this is a...
But you need a lot more than just a few flashcards. You need a ton of images, and they need to be diverse.
Diverse.
Different angles, different lighting, different backgrounds. Think about it. A cat in a sunny living room looks very different from a cat hiding under a car in the dark.
Oh, I see. So the model needs to be able to recognize the object no matter the context.
Exactly. The more variation you have in your data, the better the model will be at generalizing, at spotting that object in new, unseen images.
That makes sense. But gathering the images is just the first step, right? We need to actually tell the model what it's looking at.
Absolutely. That's where annotation comes in. It's basically drawing boxes around each object in your images and labeling them. So if you have a picture with a cat and a dog, you draw a box around the cat, label it cat, draw a box around the dog, label it dog.
It sounds a bit tedious. Imagine doing that for hundreds, thousands of images.
It can be, but thankfully there are tools to make it easier. Tools like Labeling She that help you draw those boxes and assign labels much faster. And trust me, the effort is worth it. A well-annotated data set is the key to a successful YOLO model.
So we've got our images. They're all labeled. Now what? Do we just feed them to the YOLO algorithm and say, go?
Almost. We need to make sure the data is organized in a way that YOLO can understand. This involves creating text files with specific information about the objects and their bounding boxes for each image. It's like giving YOLO a cheat sheet.
Right, a cheat sheet so it knows exactly where to look for each object. Okay, so data is prepped, organized. What's next? Time to set up the environment where all this magic happens.
That's right. And this is where things get a bit technical, but stick with me. It's not as scary as it sounds.
Oh no, don't worry. I'm ready for the tech talk.
Great. So you'll need a few things. Python, a programming language used a lot in data science, and PyTorch, a library for deep learning.
And then, of course, the YOLO library itself, right?
Exactly. That's the engine that powers all this object detection magic. And if you have a GPU, a powerful graphics card, there are tools like CDA and CUD1N that can really speed up the training process.
Oh, so a GPU is like having a supercharger for your YOLO model.
That's a good analogy. Now, when it comes to actually working with YOLO, you have some choices. You can dive right into the code with the Ultralytics library, which gives you a lot of flexibility. Or you can use platforms like RoboFlow, which are a bit more user-friendly and might be a better starting point for beginners.
So it's like choosing between building a car from scratch or buying a pre-built one that you can still customize a bit.
I like that analogy. The best approach really depends on your comfort level with coding and what you want to achieve with your model.
Okay, so we've gathered our data, annotated it, set up our environment. It feels like we're finally ready to start training, to hit that go button. But wait, isn't there one more step? Something about model configuration.
Ah, yes. Model configuration. That's where we fine-tune everything for optimal performance.
Ah.
But before we jump into that, let's talk about something that can save us a ton of time and effort. Pre-trained models.
Pre-trained models, what are those?
Think of it like baking a cake. You could start from scratch, measuring out flour, sugar, all that. Or you could use a pre-made cake mix, which already has most of the ingredients combined.
Oh, so pre-trained models are like cake mixes for object detection.
Exactly. They've already been trained on massive data sets like the Costco dataset, which has tons of images and labeled objects. So they come preloaded with a lot of knowledge about object detection.
That's incredible. So we're not starting from scratch.
Not at all. We're building on top of what these pre-trained models already know. But of course, we can still customize things, tweak them to fit our specific needs. And that's where hyperparameter tuning comes in.
Hyperparameter tuning. That sounds intimidating.
Don't worry, it's not as complicated as it sounds. Hyperparameters are basically settings that control how the model learns. One important one is the learning rate. It determines how quickly the model adjusts its understanding based on the data it sees.
So if we set a low learning rate, the model learns more slowly, but maybe more accurately.
That's the general idea. A low learning rate means smaller adjustments, which can lead to a more precise model, but it might take longer to train. A high learning rate can speed things up, but might risk missing those fine details.
It's about finding the right balance between speed and precision, like fine-tuning a recipe.
Exactly. There are other hyperparameters too, like batch size, which controls how many images the model processes at a time, and epochs, which is like the number of times the model goes through the entire data set during training.
Okay, so we've got our data environment pre-trained model, and we've fine-tuned some settings. Now, can we finally hit go? Is it training time?
It is, and this is where things get really exciting.
Okay, I'm ready. What actually happens when we train a YOLO model? What's going on behind the scenes?
Basically, we're feeding our prepared data to the YOLO algorithm, along with our chosen pre-trained model and our tweaked settings. The algorithm starts looking at the images, comparing its predictions to the labels we created during annotation.
So it's learning, it's trying to match its guesses to what we told it is in each image.
Exactly. And it's constantly adjusting its internal parameters, trying to reduce the difference between its predictions and the actual labels. We can track its progress with metrics like loss and MAP.
Loss and MAP, what are those?
Loss basically measures how many mistakes the model is making. Lower loss generally means it's learning well. MAP stands for mean average precision, and it tells us how accurately the model is finding and classifying the objects.
So a high MAP means a good, accurate model.
Exactly. We want to see the loss go down and the MAP go up during training. That means the model is getting better at its job. This training process can take some time, though. It's not instant.
I can imagine. It's like baking a cake. It takes time for all those ingredients to combine and bake properly.
That's a great analogy. It can take hours, days, even weeks, depending on how much data you have and how powerful your computer is. But the results are worth the wait.
Definitely. So we've trained our model, it's learned. Now, how do we know if it actually works? How do we test it?
Well, remember that test set we created way back during data preparation? It's time to put it to use. We feed those unseen images to our trained model and see how it performs.
It's like the final exam after a long semester of studying.
Precisely. We're checking if it can apply what it learned to new situations. And if we're happy with the results, then it's time to deploy.
Deployment. That's where we unleash our YOLO model on the world, right?
Exactly. We integrate it into an application. Maybe it's a security system that automatically detects intruders, or a system that identifies defects on a production line. The possibilities are endless.
This is so cool. But before we get too carried away with applications, I think we have some bonus tips to share.
We do. A few extra tricks that can really help you get the most out of your YOLO model.
Okay, I'm all ears. Let's hear those secrets.
First, if you have a GPU, use it. We talked about this earlier, but it's worth repeating. A GPU can make the training process much faster.
It's like having a super-powered oven that bakes your YOLO cake in record time.
Exactly. Then there's data augmentation. This is where we create variations of our existing images by flipping them, rotating them, adjusting the brightness, and so on.
Interesting. What's the point of doing that?
It helps us create a larger and more diverse data set, even if we don't have a ton of original images. It's like adding different spices to a dish to create a richer flavor.
I like that analogy. So even if we start with a limited data set, we can make it seem much bigger and more diverse through data augmentation.
Exactly. And let's not forget our transfer learning, which we touched on earlier. By building upon existing knowledge, we can train really powerful models, even with relatively small data sets.
It's like having a master chef guide you through the recipe, sharing their years of experience.
Perfect analogy. By using these techniques, we can train YOLO models that are accurate, efficient, and ready to tackle a wide range of real-world problems.
This is awesome. And what's the most important takeaway for our listeners today?
I think the biggest takeaway is that YOLO model training, it's not as scary as it might seem. With the right tools and resources, anyone can learn to do this.
I agree. And the potential applications are just incredible. It's like opening a door to a whole new world of possibilities.
Absolutely. As the technology keeps evolving, we can expect even more innovative uses of YOLO in the future.
It's exciting to think about what the future holds for this technology.
Absolutely. And I think that's a great place to pause for now.
Okay, sounds good. But don't go anywhere, folks, because in the next part, we're going to dive even deeper.
We'll be talking about some common training challenges and how to overcome them. Those moments where you might be scratching your head, wondering why things aren't working.
We'll be right back after a short break. We're back and ready to tackle those tricky moments in YOLO model training. You know those times when you're like, why isn't this working?
Happens to everyone, right? You think you've got it all figured out, and then bam,
Yeah,
you hit a snag.
exactly. But don't worry, we're here to help you navigate those bumps in the road. Let's start with something that trips up a lot of people, imbalanced data sets.
Imbalanced data sets, yeah, that's a common one. It's
Yeah.
when you have way more examples of one class than others. Like imagine you're training a model to recognize different fruits.
Okay, freaks, got it.
You might have tons of pictures of apples, bananas, oranges, usual suspects, but then only a handful of, say, star fruit or dragon fruit.
So the model might become an apple identifying pro, but completely flunk the exotic fruit test. Makes sense. But how do we fix that? Do we just go on a tropical fruit photo spree?
That wouldn't hurt,
Mm-hmm.
but there are a few other things we can do. One is data augmentation, remember? We talked about that earlier, creating variations of existing images.
Right, like flipping them, rotating them, all that jazz.
Exactly. So we can use data augmentation to create more images of those underrepresented fruits, like our star fruit and dragon fruit friends.
So we're artificially boosting the numbers to give those rarer fruits a fighting chance, making things a bit more balanced for the model.
You got it. Another approach is to adjust the model's training parameters, give more weight to those rarer classes. It's like telling the model, hey, pay extra attention to these guys. They're important too.
So we can either pump up the data for those underrepresented classes or tell the model to focus on them more during training.
Interesting. What about overfitting? I hear that's another big one.
Overfitting, oh yeah, that's a classic. It's when the model becomes too good at recognizing the specific images it was trained on.
Like a student who memorizes the textbook, but can't actually apply the concepts to new problems, aces the practice test, bombs the real deal.
Perfect analogy. It's memorized the training data instead of really understanding the underlying patterns.
Okay, overfitting, bad news. How do we prevent it? Do we just show the model a wider variety of images? That's part of it, definitely. Having a diverse and representative data set is key, like we talked about before. The more variation, the better. But there's another technique called regularization.
Regularization, sounds fancy. What's that do?
It basically adds a penalty to the model's complexity, keeps it from getting too fancy, encourages it to learn simpler patterns. Those are more likely to work on new data.
So it's like saying, hey, model, focus on the big picture. Don't get lost in the detail.
Exactly. Keep it simple, stupid. Or maybe not stupid, but you get the idea.
I do. But beyond these data issues, aren't there also like technical hurdles people run into, like setting up the environment, getting all the software installed correctly?
Oh yeah, that can be a real headache sometimes,
Yeah.
especially for beginners. All those libraries, dependencies, versions. It's easy to get lost in the weeds.
Like trying to assemble furniture from a confusing instruction manual. You know what you want to build, but the steps are all over the place.
That's a good one.
Yeah.
Luckily, there are a ton of resources out there to help you through it. The Ultralytics YOLO documentation is fantastic, really clear instructions and examples. And platforms like RoboFlow, they offer a more visual, step-by-step approach, which can be less intimidating.
So it's like having a virtual assistant guiding you through the setup process.
Exactly. Plus, there's a huge online community, forums, discussion groups, people sharing tips and tricks, helping each other out.
It's like a global support group for YOLO enthusiasts. So even if you hit a snag, you're not alone. There's always someone out there who's probably faced the same issue and figured out a solution.
That's the beauty of it. And really, the main message I want to emphasize is don't be afraid to jump in, experiment, mess things up. That's how you learn.
The more you tinker, the more comfortable you'll get with the whole process.
Exactly. You'll start to develop that intuition, that feel for what works and what doesn't, and you'll get those aha moments, which are the best part of the whole journey.
Totally agree. But before we wrap up this part, you mentioned ethical considerations earlier. I think it's crucial to talk about that, especially as these models become more powerful and more widely used.
Absolutely. We can't just focus on the technical aspects. We need to be mindful of the potential impact these models can have on society.
Exactly. So what are some of the ethical concerns around object detection and AI in general? What should people be thinking about?
Well, one of the biggest concerns is bias. Like we discussed before, these models learn from the data they're fed. If that data contains biases, the model will likely inherit those biases.
So if we train a model on images that mostly feature men in certain professions, it might struggle to accurately identify women in those same roles.
Exactly. And that's just one example. Bias can creep in subtle ways, so it's important to be vigilant about the data we're using and the potential biases it might contain.
It's a good reminder that these models, they're powerful tools, but they're not inherently objective or neutral. They reflect the data they're trained on, and that data can carry human biases.
Absolutely. So how do we mitigate these risks? Well, it starts with being mindful of the data we're using. We need to make sure it's diverse, representative, and doesn't perpetuate existing biases.
So it's not just about the quantity of the data, but also the quality and the perspectives it represents. We need to ensure our data sets reflect the real world in all its diversity.
Precisely. And we also need to be thoughtful about how we evaluate and deploy these models. We need to test them for bias, and we need to be transparent about their limitations.
It's about using these tools responsibly, recognizing that they're not perfect and that they can have unintended consequences if we're not careful.
Exactly. And this leads to a broader point about the role of humans in all of this. While these models can automate tasks and provide amazing insights, they are still just tools. We need to be the ones guiding them, overseeing them, making sure they are used for good.
So it's not about AI replacing humans, but about humans and AI working together.
Exactly. It's a collaboration where we each bring our own strengths to the table.
I love that. Collaboration, not replacement. But okay, enough about the potential downsides. Let's end on a positive note. What are some of the exciting possibilities you see for YOLO and object detection in the future?
Oh man, the possibilities are endless. We're already seeing incredible applications in self-driving cars, medical imaging, wildlife conservation, you name it.
It's like we're giving machines a whole new way to see and understand the world, a way that we could only dream of a few years ago.
It really is. And as the technology gets even better, we can expect even more creative and groundbreaking applications. Who knows what the future holds?
It's mind-blowing. It really makes you think about the potential impact this technology could have on our lives, on society as a whole. I, for one, am excited to see where it all goes.
Me too. It's a thrilling time to be a part of this field.
All right, folks, that wraps up our deep dive into YOLO model training. We've covered a ton of ground, from the nitty-gritty of prepping data to the bigger picture of ethical considerations.
It's been quite a journey. Hopefully you've all come away with a better understanding of how these powerful models work and the potential they hold.
We'd love to hear your thoughts. What applications of YOLO are you most excited about? What problems would you solve if you could train your own model? Share your ideas, because who knows, you might just inspire the next big breakthrough.
And until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI.
All right, welcome back for the final stretch of our YOLO journey. We've tackled data prep, training, troubleshooting, phew. But now let's zoom out a bit.
Yeah, it's easy to get caught up in the technical stuff, but it's crucial to step back and think about the bigger picture.
Exactly. What's the so what of all this? Why does it matter? And that brings us to some slightly heavier stuff. Ethical considerations.
Oh yeah, that's a big one. We're talking about powerful technology here, and with great power comes great responsibility, Brad.
Absolutely. So where do we even begin with the ethics of object detection, of AI in general? It can feel like a bit of a minefield.
I think one of the most pressing concerns is bias. Any AI system, YOLO included, it learns from the data we feed it. And if that data reflects existing societal biases, well, the model might just perpetuate those biases in its predictions.
Oh, I see what you mean. So, for instance, if we're training a model to, let's say, identify potential job candidates based on resumes and photos, and the data we use is skewed towards a particular demographic.
Well, the model might end up unfairly favoring certain candidates over others simply because of those pre-existing biases baked into the data. It's like a vicious cycle.
Yeah, it really highlights how these models, as amazing as they are, they're not inherently neutral. They reflect the biases, the limitations of the data they're trained on. And that data, well, it's often a product of our own human biases.
Exactly. So it's on us, the developers, the researchers, the users, to be super aware of those biases and do everything we can to mitigate them.
So how do we actually do that? Where do we even start? More diverse data sets.
Definitely. The more diverse and representative our data, the less likely we are to perpetuate harmful biases. It's about making sure the data reflects the real world in all its complexity.
But it's not just about the data itself, right? It's also about how we use these models, how we deploy them, and how we communicate their limitations.
Absolutely.
Yeah.
Transparency is key. We need to be upfront about the potential for bias, about the fact that these models aren't perfect. They can make mistakes.
And ultimately, I think it boils down to remembering that AI, it's a tool, a powerful tool, but still just a tool. And like any tool, it can be used for good or for, well, less good.
I completely agree. It's on us as humans to guide these tools to make sure they're used responsibly and ethically.
Yeah.
It's not about AI replacing humans. It's about humans and AI working together to create a better future.
Now, that's a thought I can get behind. Humans and AI, a dynamic duo. But okay, enough about the serious stuff. Let's wrap up on a positive note. What are you most excited about when you think about the future of YOLO and object detection?
Honestly, the possibilities are mind-blowing. We're already seeing YOLO models being used in such incredible ways, from helping doctors diagnose diseases earlier to, helping to track endangered species in the wild.
It really is amazing. It's like we're giving machines a whole new way to see and understand the world around them, and who knows what amazing applications we'll come up with next. It's an exciting time to be in this field.
Absolutely, and I think that's the perfect note to end on. It's been a fantastic deep dive, hasn't it?
It really has. We've covered so much ground, learned a ton, and hopefully inspired you all to explore the world of YOLO and object detection a bit further.
And who knows, maybe one of you listening will be the one to develop the next groundbreaking application.
That's right. Keep experimenting, keep learning, and keep pushing the boundaries of what's possible with AI. And until next time, happy training.